Hey everyone, welcome back to another exciting video. Today we are going to dive into the fascinating world of imbalanced data in machine learning. In under 5 minutes, we are going to cover the key concepts and techniques that you need to know. So let's get started. First things first, what is exactly imbalanced data? So generally, it refers to disproportion between class concepts. There are classes or categories in a dataset that are not equally represented, and normally there's one class that overshadows the others, and that's what makes the data imbalanced. Imbalanced data is actually more common than you may think. Take for instance credit card fraud. You have most of your transactions which will be legitimate, but then you have the fraudulent ones which will be rare. And this creates an imbalanced data set where your positive class, the class that you really want to predict, are the fraudulent cases, which is the minority. And there are other examples, for instance, medical diagnosis, where you try to diagnose a rare disease, or even anomaly detection for manufacturing. Let's explore why exactly imbalanced data affects the performance of machine learning algorithms. The thing is, algorithms learn from well-represented concepts. So when they are faced with an imbalanced data set, they will try to map out and to really learn the ones that are most frequently and better represented. This means that underrepresented classes or categories will be ignored, and that ultimately will lead to poor performance on those classes or categories. So what causes imbalanced data? Well, there could be a lot of factors. You may have, for instance, a bias in your data collection, where you simply gather more information, more data on a specific concept than the others. But honestly, the most common reason for imbalanced data is simply due to the underlying nature of the domain. That was the case for the credit card fraud example, and it is also the case for other domains. For instance, healthcare. If you are diagnosing a rare disease, you will naturally have fewer examples of a specific condition than the other concepts. The most important thing is that you can clearly identify the issue so that you can better handle it along your AI pipeline. And how do we measure it? This is actually a very important question. So one way to do it is to consider the imbalance ratio, which gives us the proportion between the majority class concepts and the minority class concepts. Naturally, if you have higher imbalance ratios, means that you have a more imbalanced data set. Another way to do it would be the Shannon entropy. And in this case, higher entropy values correspond to more balanced data sets. Overall, there is not a specific scientific threshold that distinguishes between what is imbalanced or not. The overall idea is that these measures help us understand the extent of the problem and guide us through appropriate techniques to handle it efficiently. Now that we understand the challenges, let's talk about ways in which we can tackle imbalanced data. Although there are several strategies to do this, we are most often acquainted with two, which are the main strategies. One is undersampling and the other oversampling. So in undersampling, what we do is that we remove randomly majority class examples to balance it out. In oversampling, on contrary, we duplicate, which is not a very good idea, or we create synthetic new artificial examples for the minority class. One very popular way to do this that you may know is the SMO technique, which stands for Synthetic Minority Oversampling Technique. Also, there are hybrid approaches which combine undersampling and oversampling, and now with the power of generative AI, we can do this as well by leveraging fully synthetic data generation. So there you have it, a quick overview of imbalanced data in machine learning. We have covered everything from the definition, where we can find it in real-world domains, common causes, how it impacts classification algorithms, and even identification strategies and methods that you can use to overcome it. Now it's your turn to start exploring these strategies on your own projects. Thank you so much for joining me today. If you liked the video, if it was helpful in any way, please give it a thumbs up. Don't forget to subscribe and join us on Discord for more educational content. So until next time, happy coding and keep pushing those boundaries of machine learning.